The credit trading platform provides an easy way for portfolio managers, credit trading desks, and asset managers to source and trade investment-grade bonds electronically across multiple venues. Users can stream lists of bonds, respond and request RFQs all in one centralized place. The platform incorporates a fully integrated front-office trading and risk system with real-time P&L. This platform saves businesses considerable costs and development time to build a complex credit trading application with fully automated electronic venue connectivity. This 10-minute demo will take you through some of the key features of this system. In this first view, the menu on the left shows the different tabs that the user can select to interact with the system. The user can control which bonds to auto-quote or select manually, initiate orders, monitor order completion, and adjust other system settings. Let's jump right in. But first, a quick overview of the interface. The user interface offers a window into what the trading engine is doing. In other words, the engine has all the data to complete the trade from start to finish. The human trader simply uses the UI to interact with the engine. The workflow is organized around a series of fully customizable blotters, starting with the executor. The executor is a venue-agnostic register of bonds selected as the coverage universe. These are all the securities we may have elected to engage on the basis of their liquidity, maturity profile, or specifics of their terms and conditions. These are all the bonds our engine can automatically price. The user interface offers basic sorting and filtering. Let's go ahead and take a look at Verizon bonds in the 10-year maturity bucket. The executor exposes things like key security terms and conditions, portfolio position and aging information, and provides a comprehensive look at price generation steps from the base or clearing market, and risk penalty loading that accounts for portfolio positioning to richness-cheapness indicators that leverage our models of fair value. We can use this blotter to suspend or deactivate specific bonds in our universe, effectively taking them out of algo's reach. The staging blotter offers a view down to the level of specific trade negotiation threads. These are venue and protocol-specific orders, fully loaded with all price adjustments, ready to trade. The interface brings together records representing different negotiation protocols the way our core algo logic sees them. RFQ initiated by others appear next to RFQ initiated by us, accompanied by orders representing our algo providing firm standing liquidity, alongside records representing us taking liquidity by aggressing on some venue stack. Let's take a closer look at the market axes incoming RFQ and let's filter them further. Similar to the executor, this blotter exposes a minimal set of toggles the trader can use to allow or disallow quoting in a specific RFQ or a streaming thread. The toggles represent fork points in the algo decision tree. In a fully automated quoting scenario, trade negotiation is executed automatically bypassing the staging blotter. Actively engaged negotiation threads appear in the active blotter, which has an identical set of columns as the staging blotter. Records here represent RFQ we have responded to with a quote, RFQ we have sent out and expecting quotes back, or active firm standing liquidity streaming orders. Same as with the staging blot. The trader is offered a menu of toggles he can use to nudge the algo along its decision tree or elect to let it follow its predefined negotiation path. All completed negotiation threads are closed and are recorded in the completed blotter, which offers a comprehensive and complete audit trail of every action taken by the algo. Successfully negotiated trades end up in both the completed blotter and in the post-trade blotter, with the latter serving as the record of all information relevant for straight-through trade processing for reporting, clearing, and settlement. In addition to blotters, the engine exposes two other controls accessible from the menu in the top left corner. First of the two is a fully customizable dialog that brings together high-level levers that allow the trader to control various aspects of the algo posture. Here we see controls that a trader can use to shut off fixed connectivity in an emergency, pause or resume automated trade negotiation, dial in or out level of quoting aggressiveness. The second control provides a view of the key system components for monitoring purposes. Here the system reports everything from state of venue connectivity to error detection and pricing, and trade negotiation logic. To conclude, we should mention that the trading platform is cloud native with the user interface we see running in the browser on the trader's desktop. The platform is continuously monitoring for network connectivity breaks between server-side algo running in the cloud and the client. The algorithm suspends its automated activities if it detects loss of connectivity to the client. Connectivity detection is triggered even when users authenticated with trader privileges minimize or otherwise block their browser window. The trading application suite comes complete with reporting and analytic tools from performance analytics, cost of execution analysis, profit and loss attribution, multifaceted portfolio risk modeling, rate hedge recommendations, and relative value analytics. With basic interface elements covered, we proceed to our workflow examples. First, we'll bring up our staging and active blotters and start selecting orders for streaming. We'll pick TrueMid and UBS as our two streaming venues. Let's assume that we are interested in posting offers only. And further, let's assume that we wish to exclude Goldman and HSBC bonds. And finally, we would like to focus on the 5-year maturity bucket. The engine has already determined the quoted price we will be sending out. This price reflects our model of clearing price, or the price where we are likely to get the trade done. It has loaded the price with adjustments to incentivize risk-reducing trades and disincentivize risk-additive trades. Risk loading incorporates position aging considerations and dislocations from fair value. The blotter exposes a rich set of indicators including how much risk penalty is baked into the price, how far our quoted level is relative to the market clearing level, and what is the extent of mispricing implied by the difference between our model of clearing price and fair value. The trader has the option to continue filtering the orders set on these statistics. But for our simple example, let's assume that we are satisfied with our selection and go ahead and release these orders to the venue. We can do so order by order or release all filtered orders at once. In the auto-quoting scenarios, the engine performs the filtering according to pre-specified criteria and releases orders to the venue bypassing the staging blotter. Streaming orders are displayed in the active blotter. The algo follows the interval transitions specific to each protocol. For example, we see that one of the two TrueMid orders has entered the swarm phase. Here the trader has the option to nudge the algo decision tree logic by clicking buttons we see on the right. And finally, we confirm successful submission of our orders using the venue-provided UI tools. In the streaming context, our algo acts as a liquidity provider. Next, let's explore another workflow example. Here we will act as a liquidity taker by initiating a list of RFQ using the dealer RFQ protocol on the MarketAxess platform. Let's bring up the two blotters we already know, and, in addition to staging and active blotters, we will also open the blotter used to group orders into lists. Lists are blocks of orders delivered to the venue as a package. We start filtering our orders by selecting MarketAxess as the venue. Let's now assume this time that we are looking to buy. We focus our attention on orders where we are going to act as a liquidity taker. As we have already described, the blotter exposes a rich set of order statistics we may include in our filtering criteria. For our example, we will look to leverage our model of fair value to look for opportunities to buy bonds we consider reasonably priced relative to the model. The algo engine accepts modeling inputs from a variety of sources and is fully customizable in that regard. The models of fair value we use are machine learning models delivered in real time by the Amazon SageMaker ML training and inference infrastructure, but the algo engine is agnostic with respect to the nature of model signals or the specific delivery mechanism. As with the previous examples, we demonstrate the order selection by following manual filtering steps. In the automated trade negotiation scenarios, RFQ list composition, submission to the venue, and the decision whether to accept or pass on the quotes coming back is done in a fully automated fashion. But for the purpose of our example, let's assume that we are looking for offers in bonds where our own bid levels lie within 2 standard deviations of fair value. In other words, we are looking to buy, but we don't want to overpay in terms of our own model of fair value. We add these 23 filtered orders to the list either individually or as a block. Review our orders and send them to the venue. Once again, our orders move to the active blotter indicating that they have been accepted by the venue. We now wait for our counterparties to respond into our RFQs with quotes. Depending on the protocol, the typical quote collection interval lasts 3 to 5 minutes, giving our counterparties time to respond. At the expiration of the collection interval, Quotes are delivered into our platform, and for every RFQ order we submitted, the algo selects the best quote received. Here the inbound quotes are evaluated against our model of market clearing price. Quote responses within our model of clearing price expose hit lift toggles indicating an opportunity to trade. Let's accept the 2 quotes in Goldman and Morgan Stanley bonds. The 2 negotiation threads enter the traded interval, indicating that the venue has confirmed the trade on spread. We now wait for the automated spotting mechanism to spot our trade versus the benchmark Treasury bond to determine the final dollar price at which we traded. We use the MarketAxes UI to confirm that the 2 trades are in phase awaiting Treasury spot. At this point, the trades are considered done for the purpose of risk. Trades booking into the trading portfolio is immediate and results in full pricing re-rack across the order book to reflect a change in portfolio exposure. Once spotting versus Treasuries is complete, the venue delivers the final execution report our engine uses to process the trade for trace reporting, clearing, and the final booking into the internal trade register.